Alright, let's look at the homework 8.3, problem number 7. Alright, so we want to find the centroid of this given region. Alright, so let's do that. Alright, so let's see, let's just sketch the picture first. So we have the y-axis here, and here's the x-axis here. Alright, and you have e to the x, so that's just a increasing exponential function. So let's say it's going to look something like that. Alright, and then you're going from 0 to 5. So I'm gonna, it's not the right scale, but I'm gonna put 5 here. Alright, so we're talking about this region right here. Alright, so this is the region. Alright, so first we need to find the area, so let's find the area. Alright, so area just a simply integral from 0 to 5, and the graph is e to the x with respect to x. Alright, so antiderivative e to the x is still e to the x, and you're going from 0 to 5, so which means that they're going to have e to the 5 minus e to the 0 is 1. Alright, so this is the area. Alright, so let's find the integral from 0 to 5. Alright, actually, so since we're talking about the centroid, I'm going to assume that the density is going to be uniform and it's equal to 1, so we don't have to worry about it. Alright, so let's find the moment with respect to y-axis. Alright, so which is going to be just an integral from 0 to 5 and x times f of x, in this case e to the x dx. Alright, then I'm going to do the integration by parts. So take the derivative of this guy, we get 1. Take the antiderivative of this guy, you get the e to the x. So you're going to do, you're going to get, let's see, x times e to the x. And you're going from 0 to 5 minus 0 to 5, right, e to the x times 1, so you just have e to the x dx. Alright, so this is going to be, plug in 5, you get the 5 e to the 5, and plug in 0 is 0, so minus, and antiderivative e to the x is still e to the x, you're going from 0 to 5. So this is going to be 5 e to the 5 minus, plug in 5, so it's e to the 5, and a minus, so it's going to be plus, e to the 0 is 1. Alright, so this is going to be simply 4 e to the 5 plus 1. Alright, so we got that. And then we need to find a moment with respect to x. This is just going to be a 1/2 integral from 0 to 5 and the f of x squared. So in this case, e to the x squared would be e to the 2x with respect to x. So this is going to be 1/2. Right, antiderivative of e to the 2x would be e to the 2x divided by 2. And from 0 to 5. So this is going to be, so it's going to be 1/4. And plug in 5, you get, so I combine those two together. So e to the 10 minus, plug in 0, e to the 0 is 1. So we have that. Alright, so if you want to find the x bar, so x bar is equal to, is simply a moment with respect to y divided by a. Alright, so this is going to be, alright, so moment here is a 4 e to the 5th plus 1 divided by e to the 5th minus 1. All right, then the y bar is going to be moment with respect to or about the x-axis over a, and which we found that to be e to the 10 minus 1 over 4 times, let's see, e to the 5th minus 1. All right, this one we can simplify a little bit because e to the 10 minus 1 can be rewritten as e to the 5 minus 1 times e to the 5 plus 1. And then you're dividing by 4 times e to the 5th minus 1. So we can cancel e to the 5th minus 1, e to the 5th minus 1. You end up getting e to the 5th plus 1 over 4. All right, so let's type it in. All right, so we got here, we're going to get, let's see, 4 e to the 5th and the plus 1 and all over, so this guy over, and e to the 5th minus 1. All right, then comma, we have, let's see, e to the 5 and plus 1 over 4. All right, so then let's see, we were looking for the correct picture. So this is not the right picture, this is not the right picture, either this one or that one. And it looks like centroid is going to be more reasonable here, because this is definitely not centroid because you have a bigger region sitting on the right hand side. So it's going to be this one. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.